Welcome to the Tricolor Stomachion, an extension of the oldest puzzle known to us in the Western world. First studied by Archimedes, it was enhanced by the addition of color in 2011 by Kate Jones of Kadon Enterprises. For more information on Kadon, go to the link found between the two versions. Wow, here's our friend Archimedes himself. He must have found the puzzle challenging at first, because it is not easy to put it back together once the pieces have been put in a bag, shaken, and then spread out upon the table. Most people struggle to find one solution, and when they do, they just presume it's the only solution. Archimedes, of course, went deeper. His first question: was the solution drawn on the left the only one possible? So the question before us is this: one solution or more than one solution? It's now documented that Archimedes believed that there were a multitude of solutions, although it is also clear that he never calculated how many. About 2,200 years later, Bill Cutler discovered that there were 536 solutions. Indeed, that's a multitude. Let's first see how we can go from one solution to two solutions, and then perhaps we will understand how to get to 536. Once we understand why there are two solutions possible, we'll gain insight to build towards 536. Here's our original solution with the addition of two stars, which will help us track those two pieces as we manipulate them. First, let's slide the right half of the stomachion to the right. Now we rotate the right half by 180 degrees around its center. Finally, we slide the right half back to its original position. So there you have it. We've arrived at our second solution, starting from the first, by doing some very simple maneuvers. We know it's a second solution because all the 14 pieces still fit in the box. But as you can see from looking at the stars in the first panel versus the stars in the fourth panel, it's a different solution. We've successfully jumped from one solution to two solutions. Let's now use the Tricolor Stomachion to see how we can get even more. We've seen the original on the left transformed into the second solution on the right. We've exploited symmetry around the center line plus a rotation. Interestingly enough, most solutions have this centerline symmetry, although not all. But this solution has another symmetry along the diagonal. We can use that to get another solution simply by flipping the triangle above the diagonal to get the solution on the right. But even in the absence of symmetry, there's another way to get a second solution starting from any first solution, and that is a simple exchange of the two congruent triangles indicated by the dots. When we exchange those, the blue triangle moves to the top and the purple triangle moves to the bottom, and that is again a new solution. By combining these various effects, we can see how the number of solutions multiplies rapidly. Our standard solution is special because it exhibits both diagonal and centerline symmetry, as well as the ability to swap the two different colored congruent triangles. It's also possible to swap other subgroupings where you have congruent shapes but different colors. But we're not going to delve down into that detail for now. Instead, let's demonstrate that there are a total of 18 solutions emanating from the original using only the tactics that we've developed so far. This should help us understand how the solutions multiply so rapidly. In this row, we leave the left-hand half of the Stomachion alone, but change the right-hand half by various rotations and flips. You can see how that looks by looking at the R's in the orange halves of the 4 solutions. So we wind up with 4 solutions, including the one we started with. Now in this row, we do something a little different. We move the green half to the right of the orange half, so that the RR in that configuration is not the same as the RR in the configuration above it. Once we have done that, we then subject the orange halves to the same set of manipulations that we did previously. Once again, we wind up with 4 solutions. When we get to the diagonal symmetry, we only generate one new solution because the starting one on the left is the same as the leftmost one in the top row. So we wind up with a total of 9 different solutions, 4 plus 4 plus 1. But now we have to remember the additional factor of 2 due to swapping the blue and purple congruent triangles. So in the end, we have 9 times 2, or 18 different solutions. This is a very good demonstration of how things multiply quickly. I think the notion of a multitude of solutions has become more plausible after the last few slides. We'd now like to look at some other features that the addition of 3 colors has provided us. Our original solution is different in the sense that all pieces of the same color only touch each other at one point at most. There are no shared edges or parts of edges. Let's define a new term, a region. A region is a contiguous color any place on the Stomachion. In this case, we only have 14 pieces, but we have at the same time 14 different colored regions. There are only 6 solutions like this one, about 0.5% of the total. Now things begin to get interesting. As a result of generating the first variant, we have 2 purple pieces that share an edge, and they form a new region, outlined in white. So now from the same 14 pieces, we have 13 regions. 1 region with 2 pieces, and 12 regions, each of a single piece. There are 28 solutions like this one, a little under 3% of the total. When we get to the second variant, we notice that this time we have two green pieces that form a two-piece region outlined in white. This is the same as the first variant, in which we had 13 regions, one with two pieces, and 12 single piece regions. So this is another one of the 28 solutions that make up the total. Finally, when we get to the third variant, we have a new situation. This time we have two blue and two purple pieces, each forming its own distinct region. So things are starting to get complicated now. So we now have our first configuration that has two regions of more than one piece, giving us 10 single piece regions and two regions of two pieces each. There's 78 solutions that have this configuration, a little less than 7.3% of the total. I think we're starting to see how the addition of color adds a lot of variety into what we can obtain. Our little investigation of those four variants exposed the notion of regions and how we can have solutions that have different numbers of regions and different numbers of pieces in the regions. And this becomes quite an amazing thing. Categorizing all the solutions is a big job, but it's very fascinating. For example, did you know that there are 6 solutions that have 2 regions of 3 pieces each, 1 region of 5 pieces, and 3 single pieces? But that there are no solutions with 2 regions of 3 each, 1 region of 4 pieces, and 4 regions with a single piece each. This is quite interesting because the two configurations appear to be very similar, and yet one of them has 6 solutions and the other one has none. By the way, have you figured out why the number of solutions doubled when we went to 3 colors? I've dropped lots of hints along the way, so I'm sure you can figure it out. A small team at Cadon spent 6 months finding the answers to these and many other questions. One of the most significant results was that there are only 35 different configurations of regions over the 1,072 total solutions. Both the puzzle and the monograph reporting on all the results can be obtained from the Cadon website. We hope that we have whetted your appetite with this little appetizer. There's a lot more here, and it's all available for you to explore on your own. Thank you very much.